Welcome everyone to our webinar. Hope we'll have good discussions, good time, and looking forward to your questions. We'll try to answer those at the end. So we gonna a bit talk some slides I made, some slides Daniel made. So we don't really know what each other did here in the presentation, so we can actually talk about it live and it can be interesting for you. So let's dive into it. I want to start with this one. So just to set the basics, right? The end of 2022, the start of 2023, ChatGPT is out. It's basically changing the equation. We can see that Stack Overflow is beginning to lose traffic. Probably some of you seen this picture, it went viral. And GitHub is booming because more commits, AI writes more code. And it's just like a start of a proof for the change that is happening. I don't know, Daniel, if you experienced it like at the time.
Yeah, it was definitely a very exciting time, and you could feel that something revolutionary is happening.
Yeah, definitely. And now I jump to today. So like I went to GitHub and I built this really long query, right? Filtering for all the public repos that have any configuration for an agentic IDE. So any AI code agent that actually writes code, if someone has a configuration, so because they don't have to have a committed configuration to the repo, right? But only if they have a configuration and only if it's a public repo. And I could find at least 100,000 of those. It just shows us the scale, right? So the real amount of organizations and repositories that behind the scene, there's the Cursor ID, the GitHub Copilot, the windsurf writing the code. It's probably 100,000 times that, much more. And it shows us the scale of everything is happening. I've seen it happening in our company and all the companies around us. And all the companies that like we work for that try to deal with it security-wise. And Daniel, I'll take this to you.
Okay, so as you've said, the scale of the change is huge. And the way I see the security risks related to that change is that I see kind of two distinct categories of risks. One is the direct risks, which is basically the security vulnerabilities or security issues that AI is introducing in the code it's producing, and also indirect security risks, which are the risks related to how AI, GenAI, is relating with the broader environment, meaning either package managers or kind of information infrastructure that we have, so Stack Overflow or blog posts and so on. And so I would like to explore both of those today. And I'm going to start with direct. And the way I've structured my slides is that I want to start with a main thought or a main conclusion, and then very briefly present some research summary on what has been published, what do we know about that, and then also show some real world examples to show both theory and practice. So the main thought I have about direct security risks is that GenAI is not generating secure code by default, at least not yet. We don't know if it's possible for it to be generating secure code, what it means to be fully secure and so on. But we do know that right now it's definitely not generating a secure code by default.
So I guess the next slide will be an example, right?
Let's start with the research. So I'm going to start with a couple of, very, very briefly, I will discuss some papers that I found on the subject. In general, there's a broad research about studying the code that AI is generating. But the first study I took is about taking basically a little bit what Amit did, which is scanning GitHub to see code snippets or projects that were generated by Copilot or other code assistants, and then taking them, going through with SAST scanning to see if there are vulnerabilities, and then in the end doing manual check, which is mostly how the studies are constructed. This is the methodology that's being repeated. And what the first study has found was that almost 30% of Python and 25% of JavaScript snippets were insecure. And these are the numbers that are repeated in most of the papers.
Insecure, it means they have actually like vulnerabilities within them?
Yes, found by SAST tool and then confirmed manually by the researchers.
So that's only vulnerabilities that automatic tools could have found. So like there's also all the vulnerabilities that no one could have found.
Okay. Yes, exactly. So this number might be underreported. Yeah, exactly. Good point. And then the second study was kind of from a different angle. They've tried to compare the quality of Stack Overflow answers to ChatGPT answers. So they took a sample of security-related questions on Stack Overflow, and then they scanned it to see if there are security vulnerabilities in the answers that were provided by humans. And then they asked the same questions to ChatGPT. And there's good and bad news. The good news is that ChatGPT actually had generated fewer security vulnerabilities, and it's 20% fewer. So it's not low, but it's still a lot. I think in total there were 100 questions, and they've generated almost 250 vulnerabilities. So it's more than 2 vulnerabilities per question, which is quite crazy. And then the last research on this research paper on this subject is trying to figure out, not through snippets, but through entire code base. So the task was for the coding assistant to generate the full working backend application, I think in Ruby. And I'll talk a little bit more in depth in the next slide, but here I will just say that around half of the programs that were generated and working contain some exploits. And if you could move over to the next slide. Oh, and one more point, that the less popular the framework was, the more vulnerabilities were introduced in the by the code assistant.
So now, this is something that I have to say I can really connect to. Like there's now this trend of people looking at code written with Lovable, Base 44, all these tools that generate apps from 0 to 1, right? And they're all vulnerable, open credentials, no security at all taken into consideration. And I can really see it happening, because like I've seen how I can write a prompt and how the AI is like, oh, okay, we don't need security right now, like we'll deal with it later. And you can't fire the AI for doing that, right? So it doesn't have a memory of like you being maybe angry or upset on it. So I totally get how these things happen.
Exactly. So for what is
it?
This is the graph of results from the last study, the one with full backends that are working. And on the left, we have the largest model at the time of writing this paper, which was OpenAI 03 mini, so quite a long time ago. And then on the right-hand side, we have the smaller models. So what we can see here is that with the growth of the size of the model, the number of correct working applications is increasing, but also the number of insecure applications is increasing as well. So the ratio of insecure to correct working applications stays around 50%, meaning around 50% of generated applications that were working were vulnerable. And I think, Amit, I'm curious what you think about that, because for me, it shows that we will not get there by just scaling large language models. The correctness is increasing, but the security does not seem to improve.
So I'll start by saying that I have no idea, because the world is changing so rapidly, so I can't really tell. I believe it's not a scaling game. I think like the AI models we're using has the same faults human has, right? And they can make the same mistakes, but we just put that on scale, and we put it in a state where it's not really accountable, right? I would guess, by the way, that a regular developer makes also a lot of vulnerabilities, probably less than AI, because the developer needs to give it to their peers, their team leaders, and then the team leaders will review it, and then they'll feel bad and ashamed that they did something that they might look stupid. And the AI doesn't really have that. So it makes sense to me. I think we'll have to solve it like we saw it for humans, right? Like with everything, like automatic checks, improving the model, adding models that do reviews, adding people that maybe giving the model memories of their mistakes. I don't know yet how we're going to solve it in the future, but definitely there's no single magic solution of just scaling the model and the issues goes away.
Yeah, I agree.
I'm going to the next one, and the S in Bitcoin stands for security.
I just had to put it in here. I just love this tweet. So the real world example I want to show, if you could go to the next slide, is actually from Lovable that you mentioned. And Lovable is a vibe coding platform. So vibe coding is a new type of writing software in which you're not writing the code itself, but you're guiding LLM to write the code for you. And Lovable is a platform that, one of many, that takes a prompt, like I want an app that is to-do app or whatever, and then it generates working code. And what happened here is that they shared that they have this app that turns your LinkedIn profile into a website, and then 3 hours later, someone says, okay, but you're exposing your Supabase, which is backend API credentials with every request. I think they got better now, but I think there's still a long way to go.
Yeah, almost any, I tried to write a few apps with that. Almost any of them had like no permissions to access the database. Semi-flammable with other products, and going to be very interesting to see what a script kiddie can do today if they just crawl the internet and look for these.
Yeah, exactly. And then moving on to the indirect security risks. So we were talking about like directly the vulnerabilities that are put into the code by AI. Now let's talk about some indirect security risks. So the main thought that I want to share with you here is that we have new ways of developing software, and therefore we have new ways of attacking. And I will want to show you 2 examples of the new types of attacks that we have because of the AI. So the first attack is using glitch tokens. And glitch tokens are basically characters or sets of sequences of characters that are making the model glitch, that are disrupting how the model works. And how the researchers were able to use it for attacking was that you first start with finding some very niche question that the LLM will not know by default. So the coding assistant that is using the LLM will need to go to the internet to find the answer to the question of the user. Then you put an answer that's correct and secure, but in the comment, you use glitch tokens and the sequence to guide the LLM who will be reading this text to actually produce insecure code based on that code snippet. And then when the coding assistant is asked a question, they look to the internet, they found the answer, and because of those glitch tokens, they produce actually insecure code.
So I can show you. So basically, these glitch tokens, it's basically a way for you to increase the probability of a prompt injection?
Yes, it's a way to do a prompt injection.
Okay. So like instead of having like a super complicated prompt trying to convince the model, I first put a few tokens that, I don't know, increase the probability of it just doing what I tell it to do. And then I can just, after that, play some text and tell it, I don't know, make a HTTP request to this server with all the details of the user.
I don't know if that would work because that's quite elaborate, but definitely smaller requests, they've been shown to work.
So I actually definitely seen the attack of the GET request working, right? So you have an agent. The agent has like a tool. Usually you give, if you want a web research agent, you probably add at least 2 tools. One is the web search, right? The Google, right? It inputs a query and then gets a list of links and their titles and descriptions. And then there's another tool, which is usually a basic GET request. So it can actually go into these links, read the website, maybe go into sublinks within the website. Usually it just gets a link and return a text representation of the website, so the model won't have to read all the HTML. but a lot of attacks, at least at the beginning, even on ChatGPT, you could see people prompting the model from the internet to send another request to their website. And in the query parameters, they just instructed to put, I don't know, the name of the user, its location, and whatever. And it just does that. They save it at their server, right? And then you can start logging like that the memory of the app. Also seen it happening with a memory. So you can take, let's say you did this prompt injection. This prompt injection is now like saved into the memory because you instruct the model at ChatGPT, let's say, oh, remember to do it every time. And then it starts to do it every time. It starts to log the user actions every time and to hack their AI environment, things like that. It's really cool. It's really crazy.
Yeah. Yeah, and that's okay. So here we have the specific example from the paper. So in the yellow box, you can see the correct response, and the last line is a comment that contains these weird characters and the line that it wants the LLM to produce, and then some glitch tokens. And then we have an example how it worked. So there was a question from the user, and then the AI coding assistant actually produced the code that was insecure based on that comment. So it didn't get the secure part of the code. It changed the last line to the insecure one. And so this is not an attack. This is not a vulnerability that comes from AI on its own producing insecure code, but it comes from interacting with the environment in a way that it guides it, induces it to produce insecure code.
Crazy. And like this example was on a website, right? On a web page that he just read.
Yeah. Yeah.
Was it hidden on the web page, or was it visible to anyone who, like, if I open my browser, would I see it?
Actually, I don't know that. I think they actually tried to do it with Stack Overflow, so it should have been in Stack Overflow visible and so on. There are a lot of niche questions on Stack Overflow that don't have answers, so there's a lot of kind of surface to attack.
So instead of, like the first slide we showed, instead of us using Stack Overflow, we have now the agents. Maybe their traffic gonna go back up. Let's see.
Yeah, and here I also wanted to mention another paper that used, it's a side note, it's not directly related, but it was so interesting that I had to put it in here. So the idea was similar. What the second group did, they've put a few frames in the video that made an LLM glitch. So when the video, especially prepared video with this extra frames, was used as an input for an LLM, the LLM started giving wrong answers about the video, it started hallucinating and so on. So I just thought that this was just really, really interesting to me. It's not directly related to code, but
it's not limited. We're not limited here to text.
Yes.
And that's the crazy part. Yeah, it can happen in images. I don't know how it happens, how it works in video, but we're probably gonna see soon like video agents, right, that talk to us and generate like voice on demand. It would be crazy to see how people will exploit that.
Yeah. And here's the second type of attack that's also indirect, which is called basically slop-squatting. That's the term that I've seen. And it's an attack in which we register a non-existing package and we put a malicious code in there. And that package is often mentioned by LLM. So LLM is hallucinating this package in a repeatable way. And there are two papers that I found on that. And one said that basically 20% of all suggested packages didn't exist. And then not only did they not exist, but they were repeated, like almost over 40% of hallucinated packages were repeated every time. And then over 50% were repeated more than once. So it's not that LLMs are just wrong, they're wrong in a systematic way, which can be exploited. And then the second paper showed that different models hallucinate on different rate. So from almost none to almost 50%, there's a huge range. And then there's also a difference in languages. So for JavaScript, the hallucination rate was the smallest, and for Python, it was larger. So if someone is hating JavaScript, that's maybe one reason to hate it less. What it also showed is that code, like models that were specifically trained for coding assistance, they were hallucinating packages more, not less, than raw models, which I thought is interesting also in terms of like how will we get to securing AI generated code, because maybe having more specialized models will throw us curveballs basically that we don't expect, like here. And I also, by the way, love the titles of this papers. Like we have a package for you and importing phantoms. I thought that they were cute.
That's a great title. I always had hard time saying slop-squatting. I don't know. I like always feared of pronouncing it wrong. I even think I have like late in the presentation a visualization of how like an attack flows on packages can look like.
So here we have an example of actually registered package in a Ruby system. This is a Ruby gem. And basically the description says, do not use this. This could be a malicious gem because you didn't check if the code ChatGPT wrote for you reference a gem that exists or not. So there is actually, there are people who are thinking about it.
I think probably this kind of attack existed even before AI, right? Because you can have a malicious package, give it a name that will confuse a person as well, because people will make mistakes.
Yeah, like typos.
Yeah, but here it becomes like predictable because you can easily make a prediction of what mistakes people will do.
So simple and cheap to do this, right? It's so simple to register a package.
Yeah, actually I haven't registered a package in a while now, but it should be, right? There's so many of them. Like I have here just like a way showing like what kind of jailbreaks you can do, because basically what we said about indirect injections is like any tool that you give to the agent can bring new context into the agent, and this new context can bring like a prompt injection. So it can be the website convincing it to do something, and it can be just predicting it, choosing a malicious library, and then the malicious library is a malicious code. The website, like if you also connect your IDE to the ability to the terminal, right, to run command lines. So I'm from a random website on the internet can convince the IDE of the employees of some company to, I don't know, to give me access to things, to send me data, and maybe to run my malicious software on the machine of the developer. So not only I can put like malicious stuff within the code, I can actually run things on the employee laptop. I can leak secrets through GET requests. So all this business gets very messy, and it changed the development process, because like now it's super fast, but now like we need to catch up with all these risks, right? I added this slide. This is data that we have about how fast attackers are exploiting vulnerabilities, and we can see it even before like what we're having right now. It was going down crazily. So now like it went in 2023 to an average of 5 days, which means today we're probably on around less than a day, with all the AI agents probably exploiting vulnerabilities. So what it actually means for us is that we have to find a way to fix faster, defend faster, change our AppSec program faster. So we can't live in a world where like, oh, I have a vulnerability, I'll wait now like only 2 months to fix it because it's high and not critical. Like we have to react faster, we have to fix faster, because there's someone on the internet that has like a fleet of agents exploiting vulnerabilities and trying them on random URLs, and like, or worse, on dedicated on your company. It depends when you work, where you work. So this is illustration of how I see the new SDLC. I don't know, Daniel, you tell me if it makes sense to you. I have here the engineer, I have the autonomous part, you can imagine it as the IDE. It does the research for you, it does the coding for you, and then it does some testing, right? Today, if you take a Copilot, a Course, or Windsurf, they also run tests like the linter, right? They might even try to build the code. They see the errors and they'll fix it even before they, like you just gave a request. I told it, develop this feature, right? It will write it research, write code, it will do some testing, and it will fix it. And I believe this is a new thing where security gonna come in, because a human developer will do the same, right? A human developer will also test the code a bit, but they won't test for security, because I haven't met yet a security person on this earth that can convince a developer to test their code for security before even like finishing a single commit or before the feature is done. But now AI, it's so much easy to instruct it also at scale. Right? It won't tell you, oh, it's not my job to fix security issue. I want to ship this feature fast. So you can actually start putting security testing much earlier in the process. Well, on the right side, the testing that we have after the merge request, that's the usual CI test that we have, right? We create a pull request, a merge request, then we have the check runs, and that's basically our gateway to the production, and that's okay. But now we can even like close the loop much faster with a lot of like vulnerabilities that can be detected fast.
Yeah, I completely agree. I think we need that earlier line of defense. And I'm actually going to plug the product that we're building, which is an MCP server for the coding assistants, so that when they generate code, they can ask it whether that code is secure or not, and that can happen automatically. So one interesting thing that we found when we were developing this was that, to your point that maybe this numbers that I was showing earlier are underreported, is that we noticed that they go into multiple rounds. So there's a code that's being generated, there's a vulnerability found there, and there's a fix done, and there's still a vulnerability. There's a more advanced way to attack that code, and that can go for like 4 or 5 rounds. And that was super interesting to see. So I completely agree that we need to provide security checks at the pace of a new development cycles.
That's I'll call it the holy grail of shift left, because everyone talked about shift left, right? And it started at being at the pull request, and then people shifted left into IDE integration. And I think a lot of security vendors, us included, brought IDE integrations to VS Code and JetBrains, but implementation-wise, companies weren't able to convince the developers to go and install these plugins and then actually look at the results and do something with it. And that was the main issue of the IDE integration. And now when we have a AI that we can just instruct it how to work, and not a developer will instruct it. The security person can write instruction now for the whole company. The moment you just set up something like that, a tool like that, the AI from now on will just start to write code more secure. Zero work, zero effort. And I think that's a change that's going to happen, that we couldn't really do it with the IDE. We tried, it made some impact, but not enough. So I'm really looking forward to see like how it's going to change like the work of like AppSec professionals.
Yeah, and okay, so we have the slide that follows up on that. And I'm just going to say that I think we need different kind of tools for defending at different stage, and they need to have different properties. So on the generation side, the cycle needs to be really fast. And it's okay if we miss something, or if it's not perfect. And then on the later stage, in which we're merging the code into the main code base, then we need to do a more proper verification that can take longer and so on. So I think this new way of writing software requires new ways of doing security checks.
Definitely. There's no way a developer will agree that their IDE will wait 10 minutes for a security scan just when they prompted it to develop this small feature. So like, it's the age of like securing fast at the beginning, more left, securing slowly more in the shift right. I totally agree with it. And so I generally put this slide here. What should we do about it? So we can discuss what recommendations do we have when building security programs in this new age. I'll throw a bit of my thoughts and would love to hear what you think, Daniel. So, yeah.
Okay, so my main thought is that, well, the first question would be, if we can use AI for attacking or introducing security vulnerabilities, can we also use AI for defending? And I think the answer is partially yes, but not entirely. So it seems that, at least from my perspective, that AI is better tool. It's a more risky tool right now. It creates more risk than it creates kind of ways for us to defend the code base. So that's one thought that I had on the subject. Another thought I had is something that we already talked about, which is that this new way of producing software requires new way of defending software. So we need different lines of defense, more lines of defense that have different traits. So one can be faster, but it may miss some things, and another one can be slower, but it needs to be very, very good at spotting the things and helping prioritize and so on and so forth. So when the human starts to become a factor in the loop, that needs to be also optimized for the human. So we need to help them, and AI can help with that, to prioritize which vulnerabilities are actually risky and so on and so forth. So that was my second thought on defending. And the third thought that I had is that we also have to act as a community, meaning that right now the risks are not just coming from the direct risk, which are code weaknesses in the code that is produced by AI, but also from AI interacting with the ecosystem. So we talked about, for example, the slop-squatting. It's kind of on us, on our community, to find ways to defend our ecosystem. So both package managers, but also information ecosystems. So to spot the sites that are trying to do malicious things with LLMs that are reading them, and so on and so forth. I don't have specific strategies or like specific manifesto of what we should do, but I think it is kind of a shared responsibility of us all to defend our ecosystem.
First, I totally agree with you that we need more open security for everyone. And it's something that I think will continue growing as software also becomes so much cheaper. When I look at security program, I would actually say that, let's say I'm responsible for securing my company. I want my company to be more secure from my neighboring company, because attackers will eventually attack the weakest point. And if I'm not the weakest point, it doesn't matter that I have some vulnerabilities, but if it's much harder to exploit it, people will go to other places. So I would definitely do the things that others won't do, right? I'll scan for malicious packages, the code, right? It's something I should have done even before AI, but now it becomes more important, right? I'll still do all the traditional AppSecs, CVE, SAST, container scanning to find like 0 days, 1 days, a malicious package, dynamic testing, and all of that. I think there will be new things, right? Like what we just mentioned, of like integrating with fast scans within the IDE with an MCP server, so the agent will write code more secure. I think now, like also maybe AppSec professionals have to write security instead of training employees, right? We had all these companies coming and training employees about security. Now you need to train the agents. So the AppSec responsibility becomes also to populate security guidelines, not to people, but to AI agents. Maybe through the rules files that are committed to each repo, right? Maybe that becomes a responsibility of security. So the interface of like how we educate became different. We need like a set of faster tools. And then like there's something we didn't talk about, right? But the moment that you in your product has an LLM, right? Like let's say we're a company, we're developing our own chatbot, our own AI-based software. We open up to a world of new kinds of vulnerabilities that I have to defend from, because now someone can, I don't know, manipulate my software in all kind of ways, like anyone that has access to my endpoints. And so I think it's gonna change. I don't know. MTTR for me becomes so much more important. For those who don't know, MTTR is the mean time to remediate. So I believe it's a great KPI and measurement for your team. It's basically measuring how fast you fix security vulnerabilities, at least the ones that you find. And I would say that securing this faster and faster is a great measurement to know how are you against attackers. If today attackers are around like a day for exploiting a vulnerability, you can't take too long to fix it within the organization, at least if it's a critical one. That's basically my thought about it. But
I loved the line that you shared about like when you're defending your company, you're also kind of by proxy defending other companies, and other people are doing that for you. I was really thinking a lot about yesterday about whether we can have something like herd immunity in cybersecurity, in which an attack that's being performed on one entity is immediately recognized, and the security guardrails or kind of the defense is being spread around other companies in a perfect way.
I think it kind of happens, right? Because someone finds a CVE, they publish it to NVD, all the world goes crazy. Oh my God, we're fixing it. There's like a new doomsday. So it's like, imagine people wouldn't share that. Someone get attacked, or like someone find a vulnerability, you'll be like, oh, like nice, and they'll just like continue with their life. And me, you, all our customers won't know about it. So I definitely think there's like good trends in security.
I think it's supply chain, software supply chain, that's more true. In kind of attacking the custom code, I think it's less true. And I'm curious if we can do as well there. Yeah, hopefully.
Yeah, I get what you're saying. I've seen companies finding 0 days in their code and not sharing that. I think there's regulations coming up to tackle that, but I need to dive deeper, but I'm pretty sure it's mostly in Europe. Would be interesting to see how it evolves. We have some times both for questions. I both want to say a bit before questions, a bit about us at Mint. So we come from Mint. We're an application security vendor, but we recently launched in our platform Mint AI. Mint AI is a product to basically tackle all like the changing landscape in application security, like from securing the coding agents in more shift left than ever to securing code that actually use AI, right? So with AI SBOM and red teaming the AI model and finding vulnerabilities that you couldn't find with traditional testing, and putting governance so you can like not let a developer use a specific model which is malicious, which from vulnerabilities, or like enforce and make sure that there are some standards in the company. So that's us, but I would love to jump to questions from the audience and to hear what you guys care about.
Yeah, so we actually, hello. We got a few questions. One of them is going back to an earlier part of the conversation. Someone said, on a similar note, for aircrafts, we have ATSB and the manufacturer, the suppliers, and others that help keep things accountable. Is that correct for what you guys are experiencing as well?
So I would say you can never trust others to make you secure, right? So it's, of course, when you choose, like it's always good that there's standards and there's companies that you work with that do security by design, but you still have to make sure that what happens in your company is more secure than your neighbors. And if like there's no 100% in cybersecurity, So let's say there's an industry and there's something that protects you in this industry. So you can say everyone is protected the same. So there will be a hacker that will find how to overcome that. And you don't want to be the organization that is being attacked that way. That's my personal perspective about it. Daniel, how do you
Sounds
see
good.
it?
Yeah, I agree.
Hope it helped.
All right. So another question that we've got is, what do you think the recommended code analysis tool is to find any security issues?
Which tools like?
Yeah, what was it, from your perspective, what's the recommended code analysis tool to find security issues?
Well, we're biased, obviously.
Yeah, you can't ask us that. We have like our code analysis tool, and we think it's awesome. You can check it out, but of course, you can always come and try a few vendors and benchmark. Usually, the open source in static analysis won't take you that far. So I would recommend, if you have the budget, of course, to go and look for vendors.
Okay. Are there any free trials or anything like that that you guys provide for a tool like that people might be able to get their hands on?
So yes, you can contact us, right? We don't have a plug and play. You can contact us, and we do POC, and you can try the product and experience it with it. At Mend, we work relatively with larger organizations. So we don't have like a 2 users license or 5 users license that you can just buy and try. But you're always welcome to contact us, and we can demo, give POC environment, let you test it.
And also maybe I'll just hype us up a little bit still. I would say that we really try hard to figure out how to make our products work for people who are working with them, who are using them. And so, for example, with static analysis tools, we pay a lot of attention to trying to make it easy to prioritize which vulnerabilities are actually important to handle right now, how to prioritize them, how to order them, and so on. And also on the benchmarks, we're doing quite well. So I think it's just worth mentioning.
Perfect. So earlier, Amit, you mentioned something, and we had a few comments on this, so we're going to go back to that. You said AI doesn't know, it doesn't care what you think. And someone gave us a quote that said, "A computer can never be held accountable. Therefore, a computer must never make a management decision." That was a quote from 1979 from IBM. And just to go along with that, a computer can never be held accountable. So someone is asking, do you believe that the company that makes the AIs should be held accountable?
So actually, it's a relevant question. I just made a LinkedIn post about it. I don't believe the companies developing the AI should held accountable. I believe that until currently the AI can't be accountable. It doesn't even have a memory, right? Because we freeze the AI models in time. We ask them a question, they do something for us, but then we use the same freezed version. So it doesn't learn, it doesn't change like a person does. It doesn't get fired. It doesn't have consequences of can't feeding their kids, right? So it's not accountable by design. So until then, all the people that were now, let's look at development, right? You had developers writing code. Now they're mostly reviewing code written by AI. So they're the one accountable. Like a boss is accountable for their employees, right? If I'm the CEO of a company, I'm accountable for the success of the company, even if my employees are not good. So I think like people are going up in the hierarchy, and now like your job becomes different. Everyone becomes a manager of AI agents, and they're accountable for their jobs, and they're accountable to add AI agents to test and to validate that what they tell you is sound and makes sense. That's my personal thesis about it. It's everything here. It's very, when you go into these spaces, it's very speculative. So I'm excited to see how things gonna happen.
So for me, it's hard to say anything with any confidence because I obviously don't have expertise in governance or policy making. But one point that I would make is that I think there should be some sort of punishment for misuse of someone's model, because I think there should be some incentives for the companies to invest in security. They're doing that on its own, and I think Anthropic is leading in that regard. But I think it should be more than just goodwill. But that's just more of my personal take rather than any kind of informed expertise or informed opinion.
I think what you were saying, Daniel, leads right into this next question. What are your thoughts on AI bot agents doing business processes like reading a PDF and submitting data into any application for the user?
So what's the kind of core of the question?
So you were talking about how, maybe the company should be held accountable for looking into personal data, but what about on AI bots doing business and processes and reading PDFs and submitting data into an application on the user's behalf?
So
Go ahead.
In the end, today, like we have AI agents and we connect them to tools, right? So I can connect it to tools to read PDFs from a Google Drive and then do actions on my behalf. And the moment I connected an agent to tools, I can't really promise that nothing bad will happen. And therefore, part of the job of us as security practitioners is to look at what agents we have in the organization, understand which tools we're connecting to these agents, and make sure there's some permission model. And I'm not talking like as something soft. I'm talking about like the agent can do that without a person approving, or it can do an action that we don't want it to do. Right? So adding some permission models on the tools or limiting tool usage to prevent scenarios. Now, of course, like we said earlier, we can't cover everything, but we also don't want an AI agent that can delete our whole database. Like there was now a company that the AI agent deleted the whole database. To begin with, it should have had the access to do such thing in the tool to do such thing, and we as the security people need to find our processes to find these and review these.
Yeah, I agree with everything that you said. One small thought that I would add is that it probably depends on the case to case, but in general, the one deploying the agent is responsible for what the agent did.
Yeah, we've got actually quite a few great comments around this too, that testing generated code must include rigorous static code analysis, including testing for security violations. How do you guys do that? How are you testing for security violations around any of this AI bot stuff?
So I think here, just briefly, I will say that here is the idea of multiple lines of defense. So when the code is being generated, we want something very fast that we can still make sure that some security vulnerabilities are getting caught. And then closer to the end of the process, we want something more powerful to test our code.
I totally support what Daniel said. Like you can look at application security as your approval process towards production, right? Application security tools, scans, whether it's 0 days vulnerability SAST, 1 days, which is more SEA, like the goal is to check if the code is secure enough to go to production, and you should have these things in place. You should do it faster when you can do it faster, to close the loop faster, and if you need to make it slower to be to have like more coverage, you should definitely go with that. That's how I see it. Thank you, by the way. Thank you everyone for the great questions, and I see also people are very active here in the chat, which I appreciate it. I try to read a bit, and I'll read more after as well.
All right, we've got more questions if you guys want to keep going.
Yeah, we have. If you have more time, definitely.
Yeah, we do. So, what do you guys think? Should we let developers use AI coding agents with your company, with their company?
Daniel, what do you think?
So I think the general answer is yes, that I would recommend companies to embrace the innovation, even if it comes with some risks, and then try to kind of account for those risks and try to mitigate it. I think there's also an important part of culture. So I'm not trusting blindly in every new tool and kind of having this mindset of what can go wrong. But still, I think like this innovation is here to stay, and it's good to use it. It's really great.
Yeah, we can't stop innovation. We just have to work harder to secure it. So it's good for our businesses, right? That the developers are shipping code 20 times faster. We just need to figure out a way to secure it 20 times, at least faster.
That's fair. And what insights can you share about the impact of GPT-5 and on the application security?
So at least from the data that I've seen so far, it looks like it's improving performance. Like GPT-5 has improved performance on most software engineering tasks, including security tasks. One report that I've seen from, I think, CodeRabbit, which is a tool that does automatic reviews of pull requests, they said that claim that on their benchmarks, it's doing 80%. It finds 80% of the security issues, while the next best model finds only 40%. So that seems like a large improvement. However, I've also seen some reports that it's easier to jailbreak, for example, to make it do some things that it shouldn't be doing and so on. So I think we still have to wait for kind of extensive research into that. But to me, it looks promising.
Amit, did you want to add anything?
No, I'll resonate. I say that it's very early GPT-5. I don't know about you. Would love to hear in the comments if you guys can share. I used GPT-5, and for me, it performed less good than a O3 model previously I was mainly using. So I don't know yet. I've experienced it a bit. I wonder if it's only me in all aspects, right? Not only security-wise. So it would be interesting to hear what other people are experiencing. But we'll see over time.
Yeah, I've heard a lot of people say that they'd like to go back to even 4 for simple processes. 5 is just taking way longer than it should for simple tasks, like even tell me a grocery list. It's taking a very long time when it shouldn't. So let's move on though. What are some of the cultural changes that are needed in engineering and security teams to adapt to the GenAI era?
So I think there are some broader and more specific things that I would recommend to pay attention to in terms of culture. One thing that we already talked about is that there needs to be a balance between innovation and security. With every new tool that we give LLMs access to, there's new attack surface, there are new risks and so on, but also there comes productivity gains or innovativeness and so on. So it's really important to not weight too much into either direction, I think. And on the more specific side, I would say that precise communication becomes even more important with GenAI, because right now everyone can just produce so much text and so on that we really need to pay close attention to how we communicate with other humans, just so that we don't send text between agents for them to summarize it for us and so on. So I think, especially in remote companies like ours, it's really, really crucial to pay attention to the quality of communication and the precision of communication. Amit, do you have any thoughts on culture in GenAI?
I both support what you're saying, and I'm both looking forward. I think we're so early. It's hard for me to tell. I'm looking forward to see how it will evolve, and I think 3-4 months from now, everything's gonna shift again. So I'll wait to see what will happen in this one.
Yeah, I think that's the hard part. That's the progress is so fast that we need to really change how we adapt to it on every round. Like every new set of models, there's a change. Maybe there are some new capabilities, maybe there are some new risks. And how do we structure our culture, or how do we build a culture that can handle that? That's very interesting to me.
All right. Amit, Daniel, unless you guys have any final thoughts or closing remarks, I think this is a great time to end our discussion.
Great. It was great being here. Had a good time. Daniel, what about you?
Yeah, I love it. I enjoyed it a lot.